Hello everyone. I'm sorry I couldn't attend the meeting, so instead I created a little recording so you can learn more about swapr and wrapper. Wrapper is a very simple contract. Essentially you can take some STX tokens and wrap them into a fungible token with a wrap method and a unwrap method, and of course you can also transfer things. And the second contract is the swapr contract. Essentially it's like Uniswap. You can check it out at uniswap.io or uniswap.exchange in the ETH world. Essentially there are two types of participant: a liquidity provider that earns a small fee on the transfer and provides the service, and the user will pay a small transfer fee. Essentially it's set at 30 basis points. The main thing versus swapr and Uniswap is that there's an invariant, which is the amount of token X and Y. When you do the product of it, it will remain constant no matter what you do. So if you want to add a little bit of X plus dx, to get and exchange some Y token, X plus dx times Y minus dy should still remain equal to K. That means that you can extract from dx known and x and y, of course, known. You can extract dy. Alright, let's take a look at the wrapper contract. There's essentially three methods: wrap, unwrap, and transfer. Wrap essentially will send STX from the sender, the caller of the contract, to the contract itself, and the contract will send back some wrap token, which is a fungible token, and update some balances. And basically the unwrap method is going to do the other way around. It's going to send back STX tokens and extract some of the fungible token, the wrap token, from the sender. That's where, instead of keeping the token, it might be a good idea to have a burn method on the fungible token itself. And the third important method is this transfer method that makes it look like any other token like we have in the basic examples from the SDK. Also included in the repo are some client methods for both the Clarity SDK, that's what we're looking at, and the transaction, the stacks transaction. That makes it a lot easier to use the contract. Here's the wrap methods. There's the same parameter as a contract, and the unwrap method, same thing, the amount and who the sender is, and the transfer methods as the same parameters as well. Here we see the unit test where we can call the wrapper contract, check the balance, call wrap, call transfer, and things like that, and just check that everything works as it's supposed to do, and that's what the tests are for. Right now let's look at the swapr contract. Here we're looking at add position. Essentially it's something to add liquidity, so you add X amount of the token X and Y amount of the token Y. This is going to call and that's why it's important to have the swapr contract, for example, that answers to the transfer method. It's going to transfer X amount from one token and Y amount from the other token, and then update balances both at the contract level and the sender's level. The second method that liquidity providers will use is to reduce position. It's a percentage, so to close your positions you just use 100%, and it's essentially going to do the reverse that add position did. Transfer back tokens to both X and Y and update balances accordingly. And here we have one of the 4 swap methods, swap exact X for Y, which is going to, and that's where you see the full formula with the fee calculation. And with integers you have to be careful about not dividing something too small, so instead of using 0003, it's using 100997, which is the equivalent, which is the same thing as 30 basis point, not 3, sorry. And once it calculates everything, it's going to transfer from token X to token Y. Essentially, it moves the token X to the contract and sends you token Y's from the contract. For the wrapper contract, we looked at the Clarity SDK type client. Here we're looking at the stacks transactions client with one interesting addition, which is the wait for TX, which instead of waiting like a set amount of time, 10, 20 seconds, like some example is showing, it's actually going to query the sidecar server and to figure out, based on the transaction ID, whether the transaction is completed or not. Here's how the implementation works, where it's going to use the sidecar URL, the v1/v1/tx, and wait about half a second between each query and return success. If after the amount of time, the max wait, then it's going to throw an exception instead. And one interesting thing to note is that the transaction with the modified version of sidecar that I'm using actually includes the results of the transaction, both in human readable and X. And this is actually a clarity value, so you can use the deserialize function to actually get the result back that you can use in your test, or if you write a real application in your application. So to deploy the actual swapr contract environment, you need the trait description, you need the wrapper contract to use as a token, you need two other tokens, token 1 and token 2, so we're going to be able to exchange token 1 and token 2 and wrapper and token 1. That's two instances of the swapr contract. So with the transaction client that we have, we're going to then be able to set the fees, call add positions, and check the results straight away. And it's going to wait the minimal amount necessary to get the results and no more than that. Right now, let's run the test. We're going to run the unit test first. It's just a simple npm run command. Nothing services, no extra services needed. You can ignore the green stuff, that's extra debug that I have in some of my services running. Yeah, that doesn't make it very pretty. Now to run the transaction test, the integration test, we need to run the sidecar. I've got my own task, so I can run the Bitcoin server and the Postgres server from Docker, but running the stacks node and the sidecar node, sidecar server outside of Docker, so I can use my own versions. So hence the custom run function. Okay, let's start it. We're going to wait for the stacks nodes to start generating the blocks, and then we can switch to the other tab to run the actual integration test. There we go, starting to generate some blocks. So we're going to run the wrapper integration test here. You can see it's deploying the contract, waiting a couple seconds every time. It's half a second for each iteration. Like waiting 20, waiting 19 is half a second. And we can try to see if we can see the debug logs from the contract in the actual stack server. Let's see, here we can see there we are. And we can see also the queries to sidecar. Alright, so we need to restart the sidecar to run the swapr tests, so start back from a clean environment. Since we're redeploying the contract, you can only deploy the contract once. wait for the blocks to start generating. Okay, alright, we can run the test so it's another npm command. It's going to deploy all the contract necessary. It's running a little slower than usual. Usually just a second and a half is enough. My machine must be doing something else. Maybe a backup. Ooh, there we go. Long wait. 5 seconds. So it's wrapping some tokens. STX. Checking balances. Then setting the fee. And we're going to do some actual swapping here. And check the balances. And there you have it. You can also check the debugs. The swapr contract is a little more verbose, because for real deployment you'd remove all the debugs. So here we can see a query the sidecar, and here I should do the swap of token 1 and token 2. Alright, there you have it. It's been a lot longer than I anticipated, although I cut a lot of stuff. I had like over 20 minutes of screen capture. If you have any questions, you can ask me on Discord and PSQ, also on GitHub, GitLab, Twitter, though I don't use Twitter. But anyway, I hope that was helpful. Thank you.